Hi, all. I want to thank you for joining our panel session today. This session is titled Applying Machine Learning and Deep Learning in Healthcare Administration. And my name is John Frauenfelter. I'm the Chief Medical Officer with Javion, and I have two colleagues with me today. Dr. Karl Kokendorfer, he is the Vice Chancellor for Health Affairs and Chief Health Information Officer with University of Illinois, Chicago. And then Dr. Bill Hansen. He's Professor of Anesthesiology and Critical Care and Chief Medical Information Officer at University of Pennsylvania. So welcome and thank you for your time today. I'm going to share my screen for a few minutes and kick off an overview and then turn it over to Karl and then to Bill, and they're going to talk through their sections and discussion for a brief period of time, about 10 minutes each. And then we're going to go into a discussion, questions and answers. So have your questions ready. Think about your questions as we go through our presentation here. I'm going to start by sharing my screen. And I'm going to start by pointing out that up to this, oh, my apologies. Okay, I have to try this again. Technology is getting the better of us sometimes here. Okay, we should be able to see the full screen mode. So to this point, artificial intelligence in healthcare has, for some reason, been seen too often as a data science project. And we need to get to the point where we move past it being seen as something to experiment with, something to explore or to consider, and move it into a commitment to use, commitment to have value, commitment to succeed. So we're almost a pre-contemplative or contemplative point in our journey right now around clinical AI. There's curiosity, there's interest, but still a prove it mentality when we talk about clinical AI. So if we look at what Gartner has to say about this, there are levels of maturity, and we would certainly in some places around the country, we're past the awareness stage into what we would call level 2, the active stage. And even here, there's still AI experimentation going on in a data science context. Does this work? What do we do with it? How do we prove it? And we need to get at least to the next level, operational stage, level 3, where we begin creating value by process optimization or by product innovation, service line innovation, and clinical care transformation ultimately. Now these are buzzwords, but clinical care transformation is where clinical AI is applied and changes outcomes as a result. So as we begin to create value in this level 3, I think it will pull us out of the doldrums of the novelty of AI that we're in some places around the country seem to be stuck in level 2. So what does that look like? Analytics has this, now just looking at analytics from a maturity and value standpoint, we have often, until the last 10 years, really been focused on getting data even to understand what happened and why did it happen. So those first two levels of maturity, what happened, why did it happen, let me get some information about that, and to think about what can we do differently, that's been most of the energy and emphasis up until about 10 years ago. For the last 10 years, or even a little less, last 7 or 8 years, there's been tremendous focus, and there continues to be focus on predictive analytics. And this is risk stratification by any other name, what will happen. But that's running its life cycle, and it's going to come to an end. Where value is really going to be produced is when we say, what can I do in the most efficient way to drive a different outcome? What should I do? And this is on a level of maturity. This is at the level of what's often referred to as wisdom versus just having information or data. And a clinical analytics term for this is prescriptive analytics. So as we get to prescriptive analytics in healthcare delivery, we will absolutely be creating value. We'll drive past the science project stage and begin to have this become more normal in healthcare, as it is through much of the rest of our lives. So that's an introduction and kickoff. I'm going to turn it over to Carl now in order to see some specific opportunities and value that they are driving in that space at University of Illinois, Chicago.
Great, thanks, John. Can you hear me okay?
Yes, we can.
All right. Well, thank you for the opportunity to join all of you. And John, thanks for that intro. As he mentioned, I am Carl Kokendorfer. I serve as our Chief Health Information Officer. Really enjoy working with a great team and for a health system with a noble mission for caring for many underserved and vulnerable patients in Chicago and beyond as the only state-based academic healthcare delivery system in Illinois. I lead our informatics efforts in my role in our Vice Chancellor for Health Affairs Office, which oversees 7 health science colleges, our hospital and clinics. I also have a role within our College of Medicine as a practicing family physician doing inpatient, outpatient care, and interim leader within our Department of Family and Community Medicine. Also recently received some internal funding from our Discovery Partners Institute, or DPI, to build an AI center in medicine to address wicked problems for our vulnerable populations. When I started this informatics as a career journey almost 30 years ago, I'll never forget when I took my first AI course in the early 90s. My computer science professor from the University of Illinois in Urbana-Champaign admitted to us that almost no one was using these neural network methods in the real world at the time, and only time would tell if they ever became popular. Well, here we are, and AI and neural networks are finally being utilized to solve real world problems. For full disclosure, I do have an ownership stake in a health IT company, 3 issued patents in the areas of medical search, clinical decision support, but none of which are related to the content of today's session. So let's get started. I expect us to discuss and answer some questions that healthcare executives might be asking. I hope that my experiences will help you in your own AI and machine learning projects. And lastly, I hope to give you some tips on how to make sure that your projects are successful and some things that we should all be on the lookout for soon. So to get this in under 10 minutes and to allow more time for questions, I'll look to briefly touch on topics of buy versus build, some of the cultural barriers to AI adoption that we've run into, how I think you can ensure success and measure it, and lastly, some future directions. This is a simple decision grid that I'm not saying is right for everyone, but there are some truths here. If you just need an AI chatbot to manage your incoming COVID-related phone calls, I would suggest go to market, buy one of the many that got released last year. If, however, you're a large health system or academic medical center like us, I've observed that many of my colleagues at similar institutions are starting to build their own AI and data science teams. In my opinion, this is a long-term strategic opportunity to kind of help us be more competitive. Getting good data analysts and scientists is becoming extremely difficult and costly, but it is so important to build a good team if you want to have any hope of retaining this type of talent in the future. So as John shared, we hope that these efforts are not just seen as science or research projects, but will in fact become part of the strategic planning and day-to-day clinical delivery of healthcare at our organization and yours. To be honest, at UI Health, we aren't quite there yet. I think we'll likely fall into some type of medium-sized budget where we'll have a combination of buy and build. We did build our own COVID prediction model of who was likely to get intubated, need and require ICU care, or more likely pass away from COVID. Admittedly, it took us a long time to get our data out of our system and clean it up. It didn't help that we were in the middle of an EHR conversion. After being 25 years on Cerner, I think we were their first client in 1996. We switched over to Epic in the middle of the pandemic. We showed that our model was as good or better than what was published or what was listed in our COVID guidelines. However, the guideline champions were hesitant to adopt anything that was not peer-reviewed or published. In addition, as our models become more unexplainable, there will be more resistance to adoption. So you may want to, and I think we need to take a staged approach in what models we deploy to start with to help make sure that we're building trust in what we're deploying. So I'd like to share some tips on what I think might help ensure success. I mentioned it before that it takes a village and you really need a great team, and this is a great group of smart and dedicated folks. This is just our COVID AI team that has been meeting weekly since the start of the pandemic. The upper half and right portion of this is my informatics team. Our group makes up almost 40% of the whole team. We invited different engineering teams to help to the table to approach our COVID-related questions and the different methods and approaches that they were tackling these problems and questions. And this is just part of our larger Create Wisdom Center that was, as I mentioned, funded by by a statewide initiative called Discovery Partners Institute. We're also trying to tackle issues within the neurosciences and the new field of cardio-oncology. When Dr. Anthony Chang this morning shared a slide about how computer science, data analytics, and mathematics fit together in regards to data, AI, machine, and deep learning, I felt that it was really important for me to add this and share this great diagram that was published in JAMA by Zoo a couple years ago. It shows how our data moves from molecules to genes, to tissues, to individuals, to populations, and how different types of informatics from chemical informatics, bioinformatics, clinical informatics, population health informatics, imaging informatics, and leveraging the expertise in those fields can add value to eventually produce data-driven biomedical research through data science and AI. It's been a great diagram for me to kind of help wrap my head around it and explain it to others as well. But once you've started with your talented team of the right folks, I recommend that you understand what the goals and initiatives of your health system are. This is obviously a lengthy list of areas that gets tweaked every year, but I review this with my team regularly to make sure that we are aligned with the direction of our leadership. And these are just a few of the items that our team has worked on over the years: value-based care, sepsis, provider burnout, clinical documentation improvement. I left the no-show on here because it was something that we worked on, and I'll show you what we did in a minute. But with the pandemic, this topic has also fallen off the highest priority list by leadership, in part because with COVID, our no-show rate data has been flipped on its head. My telehealth no-show rate is less, but my in-person no-show rate is higher. So now as we've provided less focus on the no-show reduction, we've now provided more focus and energy towards our telehealth strategy and diversity, equity, and inclusion at this time. But since we did some great work in the no-show space previously, I wanted to share how we measured our success. I mentioned that we recently switched our EHR over. And so we looked at Epic's cognitive computing platform. They have a no-show model version 2 that they put out. And this is considered good performance for a predictive model based on 2 health system sites that could be used across any clinics. However, one of our clinical informatics fellows at the time, Dr. John Zulueta, who's a psychiatrist, is now one of our faculty members. He wanted to figure out how to build his own predictive model and help his colleagues. His clinic-specific model was amazing. He used this data to send messages to his colleagues, letting them know which of their patients were likely to no-show in the clinic. So we actually put together a quick little table comparing the different models. His AUC performance of 0.98 is remarkable, much better than the organization-wide model that our EHR vendor put out. But as we already know, based in the literature, clinic-specific models do generally outperform organization-wide models. And so this is partly why I think we're looking to build some of our own data science expertise in-house. I think this also helps us to retain the best and brightest by doing some of this work. And Dr. John Zuleta stayed on within UI Health and recently got promoted within a year after his fellowship to be the clinic director for the psychiatry clinic. But I also need to share that in order to have trusted, well-performing models, you must validate, validate, validate. This is hard to do well. I have had many engineering teams say, just give us your data. I think that's a dangerous consideration without proper clinical oversight. We must preserve the trust in whatever we build, and that might be a recipe for disaster if we just hand it over to somebody that doesn't truly understand the data. And let's be honest, healthcare is filled with messy and missing data. I love to do what I call the sniff test, where with our initial outcomes, if it doesn't first pass the sniff test, then we need to go back to the drawing board. I usually ask our team to do some type of cross-validation with other data sets, usually require at least one other person to review the results and methodology for accuracy. I just find it is so easy to get something wrong. I can't think of a time when we've built something and it wasn't until we validated it, did we realize that something was a little off, even just a little bit. I usually strive for 95% accuracy, and if we can measure it for any of our data and solutions. Give you a perfect example of this. We polled all of our COVID patients, then realized that if we are trying to build a model for those patients that got admitted for COVID and which ones might go to the ICU or die, we quickly realized that we had a larger cohort of patients that were hospitalized that were incidentally COVID positive, like our pregnant patients. we started testing everyone that came into the hospital. They may have been completely asymptomatic. So to use them, include them in the model for patients that we're actually trying to identify as came in for COVID, it will contaminate our model. And so, until we reviewed this and analyzed it, we made sure that we excluded those patients in our model efforts. This is a quote that I heard from George Reynolds a couple years ago. "Perception is king, reality it's jester." I love this quote. I thought it was so good that it must have been a famous or popular quote that somebody else had really come up with. But when I Googled it, the only attribution was to Dr. Reynolds. But this quote has also weighed on me a lot over the past 2 years after I first heard it at a CMIO leadership summit that Chime helped to put on and Dr. Reynolds put on. The first time I started to think about the topic of perception or optics was when I first started in my current role in 2013. And my boss at the time, Dr. Jay Rue, who's now the CEO at Geisinger, suggested that my travel to a conference during a particularly austere or financially challenged time might not be perceived too well. He was right, as there is definitely some truth in this quote, but there can also be a dark side to this as well. So just focusing on optics or perception can easily lead us astray from doing the right thing. So be careful. So bottom line, if you aren't aligned with your organizational goals and people perceive that you aren't doing a good job, it doesn't matter what you do. So let me just wrap up real quick and let Bill take it from here. This is a basic workflow diagram that I pulled off the internet, so don't pay attention to any particular details. Some of you may already be incorporating your AI solutions into your clinician's workflow, but for us who just went through an EHR conversion, we haven't yet. In the future, any AI solution needs to be more integrated into the EHR. Eventually, we need to have more adaptive or unsupervised learning methods and models to improve our clinical decision support solutions. And to summarize, I'm just going to say, align yourself with your organizational priorities, get access to the best resources, which likely means some combination of buying and building, working with vendors, or building your own in-house capabilities. Engage the right clinical expertise to reduce barriers. If you want an ED doc to use a predictive model, get an ED doc involved early on. Validate, validate, validate. It's so hard to do well, but so important. So easy for a team of engineers or data scientists to go off the rails if they don't know the clinical workflow or what the data truly represents. Set the right expectations and measure your outcomes. ROC and AUC curves help to provide a measurement that most clinicians understand. Be aware of the importance of perception and optics, but make sure you're doing the right thing, and look for ways to incorporate your tools into clinician workflow. So that's all I have. There's my email, and I will stop sharing and let Dr. Bill Hanson take it from here.
Thanks, Carl. I appreciate that. Some nice lead-ins, both from you and John. I'm going to also share my screen here. There we go. That should do it. And let me just start by introducing myself. I am the Chief Medical Information Officer at Penn Medicine. We're at this point 6 hospital system in Philadelphia, New Jersey. I've been in this role for about 10 years, and during that period of time, we converted from several systems to really an Epic core. We had Epic on the campus prior to that point, but we added in elements, and now we're essentially all Epic except for Cerner Lab. So I went through the same transition that Carl mentioned. I'm an anesthesiologist and intensivist by trade, so to say, and during the early part of my role as a Chief Medical Information Officer, the areas of data science and telemedicine were nice to have, but not must-have elements. And the key focus was EMR rationalization, EMR deployment. Specifically, we did several large Epic deployments at our core hospitals, and then with acquisitions in the subsequent years, overwriting their existing EMRs with our core Epic-based EMR. During the course of the pandemic, during this last year, it's been fascinating to see the effect that has had on the importance of our data science team and on telemedicine. briefly, telemedicine just scaled up rapidly like every place else in the world. And understanding who's appropriate for telemedicine, who isn't at this point is pretty critical. But our data science team, which has been very small, we have a core of about 5 core data scientists that we recruited 7 or 8 years ago. They were originally, my chief data scientist came from Lockheed and was involved in missile identification and terrorist identification. So his backdrop was in the military defense construct. Our first recruit was a guy who came out of McGill in Canada. He was looking at jobs with us and with the Philadelphia 76ers basketball team as a data scientist, and same skills apply to both of those workspaces. I think he was inclined to do something with his patient care. I think his mother's a nurse, and so he ultimately came with us. But it speaks to people coming from outside of the healthcare industry and into it, and some of the original assumptions and misunderstandings and maybe naive expectations of what data science could do. So we started working on sepsis, and we did some very good work on sepsis spotting, but found at the end of the day, it really didn't impact patient outcomes. And then we diversified our portfolio to a degree, working in other areas, ultimately into operational areas as well. And I'll talk to you about some of the applications that we've arrived at now 7 or 8 years later that, as Carl pointed out, that align with organizational priorities. In each case, we looked for clinical experts to partner with. It's critical to have an ED doc or an intensivist or a ED throughput administrator or a coding expert. You need a partner that understands their space, but understands enough about what data science can do to communicate. We also arrived at this concept of a Mad Lib. Those of you of a certain age will remember that we all used to take long road trips in cars and entertain the kids in the back with games that they could play with. Mad Lib is one of the things that we did on our vacation. This Mad Lib is one that's sort of a traditional standard one. A vacation is when you take a trip to some blank place with your blank family. And you can imagine filling this out, that hilarity ensued. Outcome depending on the vantage point of the child. We've used that same concept really to identify what data science projects to work on. And if they didn't fit these characteristics, if I knew the following piece of information, I would undertake the following intervention to improve the following outcome. So these are critical things that we now ask upfront with every one of our data science projects. And this seems to resonate with other data scientists and folks that I talk to almost immediately. They get like why this is important. So as an example, we progress further, and as a doctor, administrator, operator, the decision-making role, it's key to fill that in. When I was, or when we were making the following decision, if I knew the following future state, I would intervene to improve what outcome. And these are sort of critical framing elements in the prior slide that has helped us get to a point now where I think we're on stage 3 on John's Gartner chart, stage 3 to stage 4, where we are actually using our data science projects in operations and clinical care to improve measurable outcomes. So as an example of some of the problems that we've worked on, which patients in my population would unnecessarily go to the ED in 2 weeks, I would do what? And at this point, we realized we didn't know what the what I would do was. We didn't have a proven intervention to prevent unnecessary ED visits or unnecessary readmissions. because we really hadn't, we didn't have a sort of a common element that would solve that problem. Everything else was in place. We had champions, we had outcomes of interest. We were talking about something that had happened in the future. So it missed a key element that we needed. Another issue was found early on in using our MadLib framing paradigm is, as a cancer specialist, if I knew patients at high risk for colon cancer, I would screen what? The PCP is the individual who needs to order the screen and was not in our original stakeholder group. So we were under the project and we realized we didn't have the right stakeholder team in place. This next issue speaks to the optics of data science. And you'll all remember the death panels in the Clinton administration sort of submarined and a right-minded effort to focus on end-of-life decision-making. We've done a lot of work to focus on identifying patients, cancer and other patients who were at high risk of dying in the next 6 months, to make sure that they had an opportunity to speak with a palliative care coordinator to define what they didn't want to do with that remaining potential 6 months of their life. Did they want to spend the bulk of the time in the hospital with a high risk of hospital and medical interventions? And we now have sort of a mandatory evaluation of all of our ambulatory patients who are flagged by the algorithm as being at high risk of dying in 6 months. They're all offered a palliative care consult, so that we can say, we can fill out the MadLib in a way that says, as a palliative care stakeholder, when I'm assigning a limited number of available palliative care consults, if I knew which patients have the most serious life-limiting illnesses, I would make sure palliative care resources are assigned to them early in the inpatient to improve the timely match between their goals and their end-of-life care. This has been received very well by our clinical community and by our patients. We're also working, just to finish off my section here, on readmissions work, on ED throughput, on coding, maximizing revenue from appropriate coding decisions, and working with our cardiac and cardiac surgical groups in a number of areas. So we now have a number of data science projects in production that are working at that sort of stage 3 level that John identified in his original talk. So with that, I'll stop and turn the mic over again to John to take us through the question and answer period.
Excellent. Thank you, Bill. Thank you, Carl, both for your expertise and also the great work you're doing in your organizations. We have about 10 minutes for discussion here, so I'm going to throw a question out to both of you. In this time where you've talked about deriving value and presenting it well to the clinicians, how do you present value to your data scientists? How do you entice them or to recruit or retain that top talent that you've gotten at both of your institutions?
I could jump in. Before we started our conversion over to the new EHR, I was helping to lead some of our data governance efforts. And to me, I realized we had data scientists scattered throughout the organization. And quickly realized that there wasn't a lot of mentorship and career trajectory for them, and that they were kind of onesies, twosies in different units and departments. We still haven't fixed it or solved it, but at least we're talking about it, and we're trying to build some of that mentoring and teamwork and connection so that they can learn from each other. And we're having, the COVID pandemic obviously was a great opportunity for us to rally all the troops and start working on something that was so critical together. and I think that helped. But I think there needs to be a lot. You need to have that. You need to have you know, the mentorship, the career trajectory in place, and some of that collaboration across people, because otherwise people will leave if they think that, you know, after doing something cool for a year or two, but if they don't see where they're going or how this could be, or if they don't feel the mentorship is there, they're going to leave.
Yeah, thanks, John. It's a good question. So part of my mandate in this talk was to talk about the C-suite perspective. I happen to sit in the C-suite in our organization. The CMIO is in that role. And the data science team originally came in under me. And unfortunately, they suffered from a lack of access to resources that were in other parts of the organization. IT, for example, sort of held them at arm's length. There was a strong desire to make sure that the team was working on operational goals that mattered. We, like Carl, found data scientists throughout the organization in research labs. We had new physician recruits who'd had experience doing data science either in their medical training or, you know, in some cases in their PhD, part of their MD PhD training. So there's been no lack of folks for them to work with. And increasingly, I would say one of the commonalities in talking to the data scientists we have is that they want to do something impactful with their work. And our team has been able to collaborate with folks in the larger city in Philadelphia and region who are part of data science collaboratives that, you know, these may be people who are working in the non-healthcare sector, but they're very much interested in contributing to healthcare at large, and more specifically during the COVID pandemic, doing something, you know, they might otherwise have been mothballed or not working. And so there's a tremendous base of goodwill and doing data science for healthcare. We've had no trouble recruiting people that were interested in working in this space. And again, I go back to that story of the one guy who was looking at working for the Philadelphia 76ers, where there's a term that some of you will know called trust the process, and working with you know, a healthcare system, and it was sort of a no-brainer for them. They wanted to improve patient care outcomes.
That's fantastic. It's great having folks like that are passionate and missional on the team and feel like they're doing good work. And then sometimes it doesn't translate to the C-suite. So Bill, a follow-up question for you. That if it doesn't translate to the C-suite, then sometimes what happens next doesn't always go according to our script. So I'm going to turn this question as a kind of flipping it as a humorous negative, if you will. What's the fastest way to have your data science team funding cut?
Well, I'll tell you. So culturally, data science guys are smart, and they come from the hoodie, you know, sort of Facebook, Google, Apple background. And, you know, we had our data science guys were flying drones in their creative workspace, while the IT kind of, you know, buttoned up white collar guys were like, why do they get those freedoms to do that with their work? And my chief data scientist has a very sort of anecdotal way of presenting, and was asked to present to a trustee board at one of our regional hospitals. Unbeknownst to him, our health system CEO, CFO, and CAO were all in the audience at this trustee presentations at one of our entity hospitals. And our guy, you know, started off presenting stuff metaphorically in a non-traditional, you know, approach that didn't resonate with either the CEO or the CFO. And they didn't understand, you know, how are we getting value? What is the value, the return on investment that we're getting from this data science team? So I think if you can't, as their champion, translate what they're doing into something that's able to be appreciated by health system leadership, they're going to get their funding cut, or they're going to get, in some other way, deprived of resources they needed to succeed.
Yeah, thank you, Bill. Now, open to questions from the audience. If you've submitted them, we'll get those funneled to us. I've got plenty of questions to ask, but and I'm having fun. So please fire questions, or you can listen to our banter back and forth. So Carl, kind of a vision question here for you. Validation and part of a culture question too. Winning over the clinician community, physicians especially, they're kind of a hard sell sometimes. And if we have to continue to go through a 5-year cycle of demonstrate, publish, revalidate, publish again, and then we're going to start to think about changing our practice, that's just a really long slog. What's it going to take for us to move into a data-driven, nimble culture in healthcare that we move faster than our ability to understand fully all of what AI can do, because we won't understand that black box fully. I can't explain why a random forest puts out this answer. So how do we make that flip?
Yeah, that's a great question. Thanks, John. And the scary thing is that time frame you talked about, maybe 5 years, actually has been shown to be up to 17 years for knowledge to make it from the bench to widespread bedside adoption. This was actually research on the time it takes done by some colleagues I had at the University of Missouri, and I think it was actually recently proven to be true again, which is still scary that we haven't made a dramatic impact on that. And we do, in my opinion, it's easy to have an AI algorithm get built wrong and could automatically steer clinicians in a wrong direction. So I do want to just start by saying, we need to be careful not to short circuit a peer-reviewed model that has served us well for 50 years, but each institution needs to weigh its own risk-benefit analysis. And there are many times when you don't want to wait for the literature. And maybe there are times we need to probably wait longer and actually let the evidence and intelligence-based medicine drive what we're trying to do. But a lot of times we can't wait that long. So and I think the best proof is in the pandemic that we got clinical evidence reviewed within weeks to months when needed, got some of the stuff out into the literature. So my hope is that we can dramatically reduce this time frame when we put our minds to it and can do it. I also think synthetic data may play a key role here, especially with such sensitive patient health identifiers that, if we want engineering and data teams to be able to work with data more easily and less risk of data breach, there's several companies out there that have built methods and platforms to help us in that area as well.
Well, thank you, Carl. Yeah, it's definitely, right now it feels like a leap of trust for clinicians, and it has to get shrunk down, or it's a baby step of trust where they say, okay, I can trust this even though I don't fully understand it. Right now it's more than a baby step, pretty clearly. With just a couple minutes remaining, I've got a question for both of you to put a bow on our conversation here today. Build versus buy, and that also includes internal access to tools at your core EHR vendor versus when would you go outside of that? So build versus buy, maybe one or two guiding principles from you both, and start first with Carl.
Sure. I'd thrown up that 2x2 matrix. One of those components was just time. If you do need to get something out the door immediately, and especially if somebody's already had something out in the market that's vetted, the phone call triage AI chatbot, I think, was a good example. There were multiple companies that had thrown something together for that. But long-term, for a larger system, I think this is a strategic direction. And so I do see us continuing to build our team, not going crazy, because we don't need to try to reinvent every role. We're not going to be able to build every AI model out there, but I think in getting some experience is going to be critical for our organization.
Yeah, I would say, obviously, key question. I think you're better positioned to make the build versus buy decision if you have the building capability in-house. So if you have data scientists that work with you, you can say, look, we could build this, but these guys can do it cheaper or better or quicker or whatever. There are going to be things that you want to sort of build in-house because there's something specific to your workspace, or you're working at a problem like palliative care. There are not a lot of companies out there that have been willing to take that on because of the potential, reputational risks or misunderstanding. I think that's something that we believe is important at a quaternary medical center, to be able to say, this care is high risk, but potentially valuable, and align palliative care versus intrusive care decisions with a patient to understand better what they're doing. We've worked on digital twins. We had General Electric come in to look at streamlining throughput through our hospital, and they had digital twins, but they would have been 7-figure investments, and our guys were able to build digital twins that were purpose-built for our area that were much less expensive and allowed us to model different staffing models much more effectively. So it's a critical decision in data science, really in all IT purchasing.
Thank you. Great wisdom from both of you. And we've seen that as well. Also, I would add just, we have to also, when you bring in a vendor, protect the trust of the data science team. It can't feel that they're threatened in any way. And those partnerships become more valuable over time. I'm going to turn it back over to Alexis and AI Med now. And thanks to everyone for your attention and time this afternoon.
Thank you.